All right, so in this new unit, we are talking geometry. So what is kind of nice about this is the fact that we're not really solving equations necessarily. I mean, they're going to be embedded, but we're going to be using a different part of our brain. So for some of us, that's going to be really nice. I'm an algebra brain, so this geometry side is always a little rougher. However, we'll kind of go along with it. So this first section that they have us discussing is about angles. And their focus more so is with triangles. So while last year you guys focused in on vertical and complementary, supplementary, and adjacent angles, if you did get to that, this is actually tied more to the triangle itself. All right, so a couple of things that we have to note with triangles is they're going to walk us through the concept of interior and exterior angles. In an interior angle, in a triangle, it's talking about the angles on the inside, interior, inside. And those three angles add up to 180. Okay, so those three angles, they have to make 180 degrees no matter what we're working with. All right, and to find that missing part, we're going to add what we know and subtract that from 180. Okay, you can subtract everything from 180, that works too. So it's kind of a tomato-tomato toss-up on what you would prefer doing. All right, but ultimately the three angles together have to make 180 degrees in order for me to be able to solve it successfully. Okay, so I want to let's do a problem just to make sure we can do that. All right, so I have here a triangle. All right, and if you need more time writing, let me know. I'm not exactly sure if you're writing or not. So we have this triangle here, okay, and I don't want to show the answers just yet because I want to see if you can get to them. All right, so I have a triangle. It's a triangle because it's three-sided. I have 53, 62, and an unknown. So the question is, what does that unknown angle have to be? All right, so I'm going to let you give it a shot. Remember, it has to add up to 180 degrees. All right, so ultimately I'm working with that number. Right? So in this problem, all right, again, we take 62, we add 53 to it to give us that, that's 11, 15. And then we do 180 minus that 115. So we would have gotten our, I don't know why I wrote an 8, 65. Okay. So interior angles, we basically got it. You know, there's this understanding of add them all and subtract. Okay. It's kind of just that base understanding for what you're doing. All right. What we also have to understand is a straight line is also 180. So if I took the three angles of the triangle and I pushed that top corner down, I would be making a straight line. So a straight line, if I go from one spot to the other, if there's this arc, there is 180 degrees tied to it. That's including if something splices it, which means if I know one of the values, let's say this is 65, I would know 180 minus 65 would get me what this other arc is worth. Now in this lesson, it's not technically going to get into the supplementary angle part of it. However, that can always help us with our understanding of solving if exterior angles is kind of confusing. So if I'm a next door neighbor and I'm on a straight line, I will make 180 degrees with it, okay? But alongside with interior angles, there is what's called exterior angles, and that's actually where I want to spend kind of most of the time, because while the concept is easier, it's an application. We have to be able to see the shapes, and unfortunately, sometimes that part of our brain is not necessarily ready for it. So I'm gonna actually stop sharing real quick. All right, so I want to show you, Edmentum did do a really nice job of being able to illustrate what this is with, all right, so let me get to slide 14. All right, and I would like to watch this with you so you can kind of get an understanding of exterior angles before we get started with it.
Hey there, I'm your friendly neighborhood delivery guy. But truth be told, this is just a job. What I really love is how angles in triangles work. Here, I'll illustrate it on top of this box. Look at this. These three lines come together to form a triangle. We have interior angles and exterior angles. Right now, let's focus on the exterior angles X, Y, and Z. Look what happens when we cut out everything but exterior angles X, Y, and Z. Those angles look a little lonely. So let's bring them together like this. Well, looky, looky. We have a whole circle here. Because we know that there are 360 degrees in a circle, we also know that the sum of these exterior angles, X, Y, and Z, is 360 degrees. Pretty cool, right? This is true of all exterior angles. Look at all the possibilities. So, for every different set of exterior angles X, Y, and Z, the sum of their angle measurements is 360 degrees.
Dude, are you gonna give me my packages or what?
Oh, yeah. Sorry. I'll just need a signature. Just don't write over my angles.
All right. So while corny, it is very factual. So exterior angles are the angles outside of a triangle. So when I draw a triangle, usually we draw three sides and they're all joining. Exterior angles are the angles that are created when I extend each of the lines. All right, so exterior angles are created when the lines extend. So each of these angles on the outside would be considered exterior. And the sum of all of the exterior angles drawn on the outside of this, and I guess I needed to draw the rest of these, huh? All right, is going to make 360 degrees, okay? So what they have us do is kind of get this understanding of what exterior angles make. All right, so I'm going to draw another triangle here. All right, and he is going to be labeled. So let's go ahead and draw this. Like so. All right, so I have a triangle, three-sided, and you're going to see that I extend out. And we're going to say that this exterior angle measure is 122. We're going to say this interior measure, let's say that that is 100. And I want to know, well, what is this inside value? So you're like, wait, what do you want from me? All right, well, there's multiple ways to look at using exterior angles. All right, the first thing you could see potentially is that 122 is paired up something here to make 180. But what they really want you to note is that this exterior angle is actually the two angles across from it when they are added together. So think about it this way, all right? 122 is paired up with a value here, and this value has to be the difference of these two. So it's kind of like this weird friendship. The values don't change who they belong to. This green angle has to be friends with the interiors, and he also has to be friends with that exterior. But he doesn't change who he is. So we need to know that the exterior is equal to the opposite interiors added together. Okay, so this angle Y has to be the number 22. Because if this is already 100, he has to be 22 to account for this full 122. So my exterior angle is equal to the sum of the two interiors that it is not connected to. right? So using this thought, I've got a diagram for us, and we're going to figure out what the values have to equal using this concept. Actually, let's do that problem again first. Okay, so here is this one. So I want to know, what is value y? I want to know what is value y. So we have 134 on this outside. What does y have to be in order to also make this true? So this exterior angle is the same as the sum of the two interior angles. So what is y's value? How much does he have to be? Nice job. Okay, this would have to be 36 because 134 minus the 98 equals 36. Because this pink spot has to make both parts of it true. All right, let's see if there's any other. Ooh, this one's an interesting one. Let's look at this one. All right, wants to know, what do the angle measures X, Y, and Z need to be if he is 100? Okay. Now, these are all the questions from Edmentum, so I want to make sure we're looking at them the way they are wording it. Okay, so I know that X and Y together have to make 100. I know that Y and Z together have to make 150. That's not quite giving me enough information. All right, I can actually get Z and X without using exterior concepts. Okay, and actually, well, there's many different ways to do this. Actually, while I'm looking at it, we can get this other exterior angle because we know the three angles together have to make a certain number. And then knowing that, we can do process of elimination. But the fastest way is to use our idea of supplementary angles, that any angle on a straight line makes 180 degrees. So if I cover this up and I have angle Z and 100 together, what value does angle Z have to be? So a straight line makes 180 degrees. What does Z actually have to be? Good. So this has to be 80. And I can do the same thing over here. Well, I have this straight line. If I know 150, X has to be how much? Good. We have to have 30 because 180 minus 150. And then if I know 30 and I know 80, I can figure out Y. Or if I know this outside the 100, 30 and what number makes 100. Or I can say this is 150, 80 and what number make 150. All of them will have the same answer. Y's value would have to be what? Not quite. So if I only put 20 in here, 20 and 30 do not make 100. And 20 and 80 do not make 150. So what with 30 makes this 100? What does Y have to be? Or you can do 80 plus 30 minus 180, whichever method we're seeing. Yes, this Y value has to be 70 because it has to require and fit all of these different criteria in order to make it work. Nice job. All right, so another type of question that they give me is located here. It wants to know what is X's value and what is Y's value. And sometimes they like to overshare. Sometimes they like to give us a lot of extra information. because sometimes we want to figure out more. So first question is, what is x's value? So I have this triangle here. So what is x's worth? Remember, a triangle equals 180 degrees. So its value would have to be nice. It would have to be 60 because 50 plus 70 makes 120, and 180 minus that 120 gets us 60. All right. What does y's value have to be? Okay, so notice this line is extending. This y value is not technically the exterior here because that would have to continue out this other way. Okay, this y value alongside with this x value is the exterior of this other triangle. So I'm going to highlight this other triangle. And notice when I continue that bottom line, my x and my y together make that exterior. So I have 60 and 50, which together makes 110. And I know this total piece has to be 110, but what is just y's value? So 60 of it is already paired here. Yep, y's value would have to be 50. So this concept of this exterior angles, it's not technically, again, difficult. It's just having an understanding where each and every part of it kind of lays. Okay, so let's do one last one. Actually, we don't even have to. You have the foundation. Let's do this one here. All right. Without me saying anything, I'm going to back it up just a little. I want to know, what is the value of A? What is the value of B? What is the value of C? And what is the value of D? So using our concept of interior and using our concept of exterior and understanding that this square represents 90 degrees, what is the value of A, B, C, and D? All right, so let's take a look. All right, B has to be 90 because he is opposite this other 90 degrees, so 90 with 90. All right, D is opposite of 90 plus 25, or we can do 180 minus 65. Both strategies will work. Okay, so D should have been 115 degrees. And then A is opposite 90 and 65, or we can do 180 minus 25 because he's supplementary to that angle there. So A should have been 155. Okay. So that's kind of angles in a big, giant, shorthanded nutshell. Typically when this is taught, it is taught over a span of 3 or 4 days. So with this little blurb, I would also encourage you to still watch the Edmentum tutorial. So they do a lot of video visuals, which will help, and then go ahead and try the mastery test.